It was just an ordinary day for Matt riding his bike.
It was just another ordinary day for Justin. Whoa, dude, what are you doing?
Oh, God.
Oh,
What are you doing?
Whoa, what do you mean?
Oh, man, come on.
This is
Where are you going?
my brand new bike.
Oh, dude, my head hurts.
Oh, man.
God.
What do you think?
doing?
I mean, skateboards, everybody knows that skateboards are always doing something sketchy.
Well, bikers are always violating traffic laws. God. Dude, my wheel. You lost my wheel.
Oh, boo-hoo-hoo.
Do you know how much wheels cost?
$10. Do you know how much these wheels cost? More than the bike.
Dude, you look so ridiculous with that helmet.
Whoa. Bro, do you understand how serious a helmet is? Do you know how important it is? It protects the brain against getting damage to the brain. It's life and death serious, man.
Oh, well, dude, I heard the brain is composed of like many different segments and things. Like, that's what I heard.
Oh, is it? Every part is very important as well, such as the frontal lobe. It affects conscious thoughts and, if damaged, can cause the social differences or mood changes. Then there is the partial lobe, which plays an important role in integrating sensory information from many different senses. Also, it aids in visual processing. Next is the optical lobe, which controls your sense of sight. And of course, there's the temporal lobe, where the sense of smell and sound and processes complex situations such as faces or locations.
Then next is the limbic and insular lobes, right? The limbic lobe deals with containing your emotion and memory, if I'm correct, and the insular lobe, which is very small and processes pain and other senses, right?
That's right. And all of those are at risk when you don't wear a helmet.
I had no idea how dangerous skateboarding was to my health and safety, to my brain. Next time I'll be more careful.
Speech. Oh, all right. And all of that was of the lobes of the brain. That's just the beginning of it. The central nervous system contains both the spinal cord and the brain. The brain is responsible, of course, for controlling everything you do from unconscious to conscious actions. The spinal cord becomes also at risk when you do dangerous stuff like not wear a helmet. And the spinal cord is a part of the central nervous system as well. The spinal cord is a bundle of nerves that runs down the back of your brain, and its function is to relay all the impulses and information from all around the body, internal and external, to the brain. If the spinal cord were to be injured, it may sever some or most of the connections between the brain and the body. Also, on top of the main central organs of the nervous system, there are also many other smaller divisions called peripheral divisions. These are composed of mostly sense receptors that spread all throughout the body. The peripheral nervous system can be split up into two different categories, somatic and
Autonomic.
Somatic is the part of the body that you have control over and are consciously doing, such as move your hand or lifting. Do you even lift, bro? The autonomic section of the peripheral nervous system deals with what you are doing subconsciously, such as breathing or beating your heart. For example, do you really think constantly, okay, but heart, keep beating. Yeah, that's good. Beat again. Do it again. And the autonomic part of the nervous system can also be broken down into two categories, sympathetic and parasympathetic. Yes. The sympathetic response deals with when you're feeling adrenaline, and it gives you the idea of the fight or flight response. And as a result, to give that response, it ups your heartbeat and increases blood flow to your muscles in order so you can make the proper response. And then parasympathetic is the exact opposite. It's the chill response, okay? So when you're chill, it just lowers your heartbeat, makes you take a chill pill. And that's what I know about the nervous system.
Cool story, bro. But how do the messages get to the brain? It sounds really complicated.
You know, I don't really know. I mean, I know that it runs through a complex system of neurons throughout the nervous system, but I don't quite understand it. It goes a bit beyond my wealth of knowledge.
You know who might know about that stuff is like my doctor.
Oh, him?
Yeah.
I heard he looks exactly like you.
In fact, he's my twin.
Oh!
Oh, Joy, let's go.
Yeah, let's go.
Okay. Could that be? Hello. How may I help you?
Hello, we were wondering if you wanted to tell us more about the nervous system.
Sure, I'd be glad to inform you of any knowledge you desire. Please, step into my office. So, what can I tell you about?
Can you tell us more about the neuron?
Of course. So, there are 3 different types of neurons: sensory neurons, interneurons, and motor neurons. Sensory neurons take a message to the CNS. The interneurons receive input from the CNS. Motor neurons take the message away from the CNS. And neurons are made up of 6 different types of things. There's the cell body, which contains the nucleus and other organelles; dendrites, which are extensions leading towards the cell body; axons, which are which conduct nerve impulses; myelin sheath, which protects the axons; Schwann cells, which contain lipid myelin; and the nodes of Ranvier, which are gaps in the myelin sheath. Here is a diagram to help you visualize. We have the nucleus, the cell body, the dendrites around the edge here, the Schwann cells, which are over here, the axon, like an axle, the nodes of Ranvier, which are these little spaces here, and the axon terminals. I'm going to give this to you so you can help visualize. Alright, so when they send messages to one another, the axon terminals meet the dendrites called synapse. They throw messages in between the 2 spaces called synaptic cleft. The chemical that helps transmit this impulse is called the neurotransmitter.
So, since the spine is part of the central nervous system, what happens to someone when they have multiple sclerosis?
Yeah, I wanted to know about this one. Well, multiple sclerosis is an inflammatory disease that causes the fat layer myelin sheath around the axons of the brain and spinal cord. It affects the ability of nerve cells in the brain and spinal cord to communicate with each other effectively, because without the protective sheath, the axon is no longer protected from the outside forces. As a result, this can frequently cause numbness or loss of feeling around the body, and in rare cases, death. Well, does that satisfy your interest?
Oh my gosh! I am so glad I got such a great, lucky chance to meet with somebody with such a great expertise in this field of research and to learn more about our ever complex nervous system. Thank you so much!
Thank you
Oh my gosh, man. Thank you so much. It's
you.
so kind of you to do this for us.
All right.
You have no idea.
Alright, see you later. Bye. Have a good time. That's great. Alright, bye. Yeah.
How much this means to our family. Oh
my god, what happened? Are you okay? What
So
happened?
painful.
What?
What happened? So cold. I think a bee got my ankle.
Oh my god.
Oh,
Let me help you up. Come on, man.
oh, 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 oh.
Here, let me help you. Hang on. I'll call you back. What happened? Oh my god, are you okay? Come in. Go home. Oh my god. Here you go. What happened?
A bee stung me in the ankle.
Hang on a sec. I got you. Ready? Okay, look at this. See here? You have what you happen here is you got stung, and the sensory receptor in your skin, it transferred that, the bee sting, all the way through the cell body. Remember that? We talked about that?
But doctor...
Hang on. Then, after the cell body, it goes through that axon that we were talking about earlier, too, all the way up to the axon terminals.
But doctor, I'm deathly allergic to bees.
Stop! Let me explain this. Okay, through the synaptic cleft, the space, remember? Then it gets picked up by another dendrite. It's so awesome. There's like a space. And it gets repeated until it gets to the spinal cord, and then it hits your brain, and then you feel it.